Hey guys, here I am back again to continue in chapter 8. Last class we talked about completing the square and the square root property as a method to solve quadratic equations. So today we're going to continue with solving our quadratic equations. There are three ways to solve quadratic equations. You can factor, as we saw in chapter 6, but factoring only works if the quadratic equation is factorable. So this only works if the quadratic equation is factorable. If the quadratic equation is not factorable, it doesn't mean it's not solvable. We'll just have to go about it a different way. Last class, or last lecture in 8.1, we talked about completing the square and the square root property. This always works. All quadratic equations, factorable or not, can be solved using completing the square and the square root property. Factoring is easier if you can see that it's factorable. But again, that only works if it's factorable. If it's not factorable, the next method we talked about was completing the square. So this solves all quadratic equations. Today, we're going to talk about a third method for solving quadratic equations, and that's called the quadratic formula. All good algebra students should know the quadratic formula. We use this in all levels of math from this point up if you are continuing in the algebra route. So this solves all quadratic equations. So we can always complete the square and use the square root property. We can always use the quadratic formula. Factoring only works if the quadratic equation is factorable. So today we are going to talk about let me see. 8.1, the quadratic formula. Oh, sorry, 8.2, my bad. So 8.2, the quadratic formula. On occasion, I may abbreviate that QF. All right, so this is yet another way to solve quadratic equations. All quadratic equations can be solved using the quadratic formula. Quadratic formula says if we're given a quadratic equation in standard form, so that means everything is on one side of the equation, and we can set it equal to 0, or we can always set it equal to 0. We put it into this form, then we can find the values of the variable by simply using this template. We have to identify the coefficients in front of the x squared term, the coefficients in front of the x term, and the constant on the end. Just a little side note here for formality. The leading coefficient is never 0. If it was 0, we would have a linear equation, which would be super simple to solve. B and C may be 0. As long as we have an x squared term in there, and that's our highest power on the variable, then it's a quadratic equation. So if we can put it into this form, then the value of the variables takes on this. It's the opposite of the coefficient in front of x. Plus minus, we'll talk about that notation in a little bit, then it's a square root of this whole chunk of stuff. Under the radical, it's b squared minus 4 times the coefficient a, which is touching x squared, times the constant on the end c, and that's all under the radical, times twice the leading coefficient. So this is our quadratic formula. Everybody, all good algebra students should memorize the quadratic formula. If you Google it or go to YouTube and there's cute little lyrics and songs to help you memorize this. So now let's use this equation to solve quadratic equations. So we're going to use the quadratic formula to solve x squared plus 2x minus 5 equals 0. First thing to identify is the coefficients. A is what's in front of x squared. B is the coefficient in front of the x term. And C is the constant dangling on the end. Now here, be really super careful. Always use your eyes and look to the left because the sign to the left is included in the identification of that value. So the quadratic formula says the solutions to this equation are going to be the opposite of the b term. So it's going to start with -2 plus or minus. And under the radical, I'm going to take this. Now, I always just mentally square it instead of writing that number squared. So I'm going to take 2 times 2 is 4. So that's b squared. That's how we got that. Minus 4 times A times C. Don't forget that C is negative 5, not plain old 5. That will give us the wrong answer. All over 2 times 1. All right, so now that we plugged everything in, we have to use our algebra skills to simplify this. So this is equivalent to negative 2 plus or minus. Now here's a good time to pull out those awesome graphing calculators. Put this in. You can put it in just like you see it under the radical. 4 minus 4 times 1 times negative 5. This right here gives us negative 20. So really it's 4 minus negative 20. So the value under the radical is 24, positive 24. Be careful because here's where a lot of students make the mistake just by simple addition and subtraction. All over 2. Now we have to keep in mind what we covered in chapter 7. All our rules still apply. We'll never leave the square root of 24 in any final answer. So the square root of 24 is not simplified because it has a perfect square factor, 4 times 6. So the square root of 24 is the square root of 4 times the square root of 6. So we're going to replace the square root of 24 with 2 square root of 6. So we're going to rewrite this as negative 2 plus or minus 2 square root of 6 all over 2. All right, what this plus minus notation means, it means that we have two answers here. We have negative 2 plus 2 square root of 6 over 2. And negative 2 minus 2 square root of 6 over 2. This just helps us to save some time and not have to write this twice, once for the plus part, once for the minus part. Now we have to go down here and we have to simplify these. Alex would not accept this as a final answer because the numerator and the denominator all have a common factor of 2. I find it easiest to split this up, keeping in mind our little algebraic property. A plus B over C can be written as A over B, or A over C, plus B over C. So I'm going to use that here, and I'm going to rewrite this one as negative 2 over 2 plus or 2 square root of 6 over 2. And then I simplify. Negative 2 over 2 is negative 1. 2 square root of 6 over 2 is just square root of 6. Now, just like in the previous section, if we have an answer that involves a radical that can't be simplified, its conjugate is always, always, always the other solution. So I know my other solution. The nice part of the number is going to stay the same, but the other solution is going to be the conjugate of this irrational expression. So we can see if we divide this up, negative 2 minus 2 square root of 6 over 2, we can simplify to negative 1 minus the square root of 6. So the answers for this problem are my solutions are negative 1 plus the square root of 6, and my other solution is negative 1 minus the square root of 6. So here's a challenge. Use completing the square and the square root property to solve x squared plus 2x minus 5 equals 0. Are your solutions the same? They should be if you do it correctly, so that is good practice. All right, so that's our first example. Let's try another one. Ready. Let's use the quadratic formula to solve x squared plus 3x minus 40 equals 0. So we're going to identify A, B, and C. A, again, is 1. It's not always 1, but just for starting out simple. B would be 3. C would be negative 40. All right, and then according to our quadratic formula, right here, here's the template for the quadratic formula. My solutions are going to take on this form. The opposite of B plus or minus the square root of B squared, 9, minus 4 times 1 times negative 40. It's all under the radical, and it's going to be 2 times 1 denominator. Special note, what goes first under the radical is always greater than or equal to 0. You never start with a negative under the radical when you're using the quadratic formula. So if b happened to be -3, would square it and would still get 9. So make sure you always start with a positive number under the radical. That can, if you remember that little trick, it can help you avoid some algebra mistakes. So -3 plus or minus, well, 9 minus 4 times 1 times -40. Well, this whole piece right here is -160. So 9 minus -160 becomes 169 all over 2. And I'm going to simplify because 169 actually is a perfect square number. Square root of 169 just happens to equal 13. We got lucky. So this is going to be -3 plus or minus 13 over 2. Right now, we're not done. If you eliminate the radicals, you have no radical or no I here, we'll do an I problem next, then we have to simplify further. So what this means, this is saying it's -3 plus 13 is one answer all over 2, and -3 minus 13 all over 2 is the other answer. So -3 plus 13 is 10. 10 divided by 2 is 5. -3 minus 13 is -16 over 2 is -8. So therefore, my solutions are x is equal to 5 and -8 using the quadratic formula. Okay, note, if we notice, we started with x squared plus 3x minus 40 equals 0. This is actually factorable. X plus 8, x minus 5. You can check, product of the first is the first, product of the last is the last, and the inners and the outers give me positive 3x's. So this factor gives me one solution, which is -8. This gives me the other solution, which is 5. So we could have solved this by factoring. So again, only quadratic equations that can be factored can be solved by using factoring. All quadratic equations can be solved using the quadratic formula. I think we have a couple minutes here. Let's do another one. Solve the quadratic formula, or use the quadratic formula to solve this equation. All right, A. Here, A is not 1 this time, it's 2. B is -4. C is 7. So the solutions are going to look like this, the opposite of B. So it's going to be +4 first, plus or minus. Now here's where it's really important. If you square -4, -4 times -4 is 16. What appears under the radical first is always positive. So don't make the mistake by putting -16 here. -4 times A times C all over 2 times A. This helps. Let's put this back so you can see quadratic formula template and where everything goes. So I'm going to get 4 plus or minus the square root of, well, 4 times 2 times 7. This is 56, positive 56. So it's 16 minus 56, which is -40 all over 4. Now previously, we said no real solutions, but now we're going to use what we learned at the end of chapter 7. Negative under a radical is equivalent to I out front. So square root of -40, we're going to rewrite as I square root of 40. And then we're going to use our chapter 7 material to simplify the square root of 40. Which is this a square root of 4 times the square root of 10. So I 2 square root of 10, or equivalently to I square root of 10. So we're going to replace the square root of 40, -40, with 2i square root of 10. 4 plus or minus 2i square root of 10 over 4. Now keeping in mind what this notation means, it means one solution is 4 plus that second term in the numerator, and the other solution is 4 minus the second term in the numerator. So we're going to break this up and simplify. 4 over 4 plus 2i squared of 10 over 4. 4 over 4 is 1. The 2 and the 4 simplify. I squared of 10 over 2. Keeping in mind we have a solution that involves both a radical and an I. So if it involves an I, a radical that can't be simplified, or both, its conjugate is always the other solution. So there's my two solutions, and you can break that down in C. Be careful. Keep in mind you also cannot simplify a value under a radical with a value outside of the radical. So therefore, my solutions are x is equal to 1 plus I square root of 10 over 2 and 1 minus I square root of 10 over 2. All right, I'm going to do one more, and then I'll finish this in a second part. Use the quadratic formula to solve x squared plus 16 equals 8x. Now remember, quadratic formula starts out by saying we have a quadratic equation in this form. So we have to rewrite this in this form in order to use this template. So to do that, we want to put it in standard form, get everything on one side, and put it in descending order. So I'm going to subtract 8x from both sides. So I'm going to do my x squared terms first, my x terms second, my constant last. So now I'm going to identify my values of the coefficients. A equals 1, B is negative 8, and C is 16. And I'm going to pop it all in. The solutions are going to take on this form. Negative B, the opposite of B, so 8 comes first, plus or minus. I'm going to take the value of B and square it, keeping in mind what goes first under the radical is going to be positive. So negative 8 times negative 8 is 64, minus 4 times A times C, all under the radical, all over 2 times the leading coefficient. All right, so let's clean this guy up. 8 plus or minus 4 times 1 times 16 is 64. So we're going to get the square root of 0, because 64 minus 64 is 0, all over 2. But we all know the square root of 0 is just 0. So we didn't make a mistake. We just have a unique situation here. 8 plus or minus 0 over 2. Well, if we break this up, 8 plus 0 over 2 and 8 minus 0 over 2 are going to produce the same result, 4. So in the big, whoops, nope, I don't think I said that yet. All right, nope, sorry, I'm getting ahead of myself. So in this case, we have one solution to the quadratic equation, x squared plus 16 equals 8x, and the only answer would be 4. So x equals 4 is the only solution. All right, so when we solve a quadratic equation, we may get the different scenarios. We may get solutions that involve radicals that cannot be simplified. They always come in conjugate pairs. Whoops, sorry. I didn't mean to make you dizzy. We could get real number solutions. And if our numbers are real numbers without radicals, then there's not necessarily a relationship between these numbers, except the fact that they both solve that quadratic equation. Oh my goodness, sorry. Or we may get solutions that involve I. The I doesn't always have a radical with it. It may or may not. But anytime you have an I and or a radical, they always come in conjugate pairs. And then the last situation we looked at is when what happens under the radical, they cancel each other out. B squared minus 4AC equals 0. So this piece becomes irrelevant. And then we only really have negative B over 2A. And that would be our only produce a one solution scenario. All right, stay tuned for part 2.